Okay, hi student. Today our lesson is a 5.6. There's an interference of wave. Okay, let's see what's the interference. Okay, first one, interference of the wave. We go to definition. Interference is a superposition. Okay, this one is a keyword. Superposition of the two waves. They're originating from the two coherent sources. So that means you want to create the interference, at least you must have the two sources of the wave. So from here, the keyword is a superposition. Is number 2 is a coherent. Okay, later we go to explain what means a super consistent and also the coherent. Okay, two waves are incoherent if they are the same frequency. So coherent means they must same frequency, amplitude must be the same, and also they are in different phase, but there's a constant. Okay, the phase maybe you up, another one is a trough, another one is a crest, but you are constant. The amplitude become the same. So that one we call coherent. Okay, superposition, the meaning means they must two sources that meet together. We call superposition. Okay, so you want to create the interference. So the keyword is a superposition of the two waves. After that, two waves must be in coherent sources. Okay, now we're going to see interference of the wave that happen when two or more waves, they are travel in the same or different direction in a given space. So same like this one diagram. Two waves, they will move same direction also can, different direction also can. After that, they will overlap. Okay. Then variation in the size of the resulting disturbance occur at the point where they are meet or overlap. So same amplitude also can, different amplitude also can. When they just overlap, we call it superposition. Okay, so just like this one diagram, from the left and also from the right, when they meet together, the maximum amplitude of the wave increase. So that one we call it superposition. Okay, this one got another diagram to show. Okay, from the left one, bigger amplitude, they meet another small amplitude. After that, when they meet at the middle, they produce maximum amplitude. So this situation, we call it as a superposition. Okay, now we got two types of the interference. Okay, if we say about the interference means superposition and also coherent, they must achieve. So when they meet together, after that, the amplitude must be equal. So the first one, there's a constructive interference. Constructive means build. You build something, make it become maximum. So constructive interference, they occur when the crest, or you say trough, of the both of the wave, they are coincide. Okay, coincide means they are overlap to produce a wave with the maximum amplitude. So example here, this one is a crest, can meet another crest, then they produce a maximum amplitude. If you say about the trough and also trough, then they produce a maximum amplitude. Okay, don't care crest or trough also can, but they must meet together with the same phase. Example, crest meet another crest. Okay, so from here you can see the red color is a crest. Then after that, the blue color also crest. Then they produce a maximum amplitude. Okay, if I'm using the trough, red color is a trough, blue also trough. Then you produce a maximum. That's a trough. So this one we call it constructive interference. Okay, now we go to another type of interference. There's a destructive. Destructive means destroy. Okay, now there will occur when the crest of the one wave, they coincide with the trough of another wave. Then they produce is a zero amplitude. Okay, we can see about this part. Okay, when trough, they meet about the crest, then they become flat. So that one we call it cosine. After that, they become zero amplitude. So this one we call it destructive interference. So interference, we got two types. One is a constructive, means you build. Okay, constructive, they will occur when crest meet the crest, or you can say the trough meet another trough. Okay, destructive interference means the crest, they meet another trough of the wave. After that, when they just overlap, they become flat. So that one we call it as a destructive. Okay, now interference of the wave, there is a result that obey the principle of superpositions. Okay, we see what is the principle of superpositions. Okay, principle of the superposition, they state that two of the wave, they are overlap. Okay, then the resultant displacement is equal to the sum of the displacement of the individual wave. So that means when the two waves, they overlap, finally they will produce a maximum amplitude. Okay, from the displacement, that means from the original, they produce a maximum displacement. So this one we call it as a principal superposition. Okay, let's see the diagram. Okay, so now we got two waves. Two also is a crest. When they're at the middle, they are overlap. So when they overlap, they produce a maximum amplitude. So this one situation, we call it as a principle of superpositions. Okay, now superposition got two crests. So that means we create the constructive interference. Before superpositions, P and Q, same amplitude, they meet each other. That means they move in opposite direction. Okay, during the center part, you'll find it they will overlap each other. So this one we call it as a during superposition. They produce two amplitude. So this part we call it as a sum of the amplitude. When they sum together, they produce two amplitude. Okay, after superposition, P and Q now move in opposite direction and go back to the original. There's a one amplitude. Okay, let's see the example. Okay, constructive interference that will occur when the two crests are in superpositions. So now this one is a fixed one. Okay, this one is a moving wave. Okay, when this one crest meet another crest, okay, you find that this one become amplitude maximum. Okay, so this one we call it as a superposition of the two crests. So we just focus to the crest. This part, crest, you meet another crest, so this one become maximum. So if I join another one, this one is a crest, this one also crest. When they meet, they become maximum amplitude. Okay, now we go to another situation also produce a constructive interference. There's a truth. Okay, now before superpositions, so you see the P and also Q, they move in opposite direction, but the amplitude now is a negative. Okay, during superposition, that means at the middle, they will overlap, they produce a maximum amplitude. Now the maximum amplitude should be negative 2 amplitude. After superpositions, P and Q also opposite directions. Means the P will continue move to right hand side, then the Q continue to move to the left hand side. Okay, let's see the diagram. Okay, constructive interference also occur when the two truths are in superpositions. Okay, not just for the crest, truth also can create the constructive interference. So we see the bottom one. Okay, this one's truth. Okay, they meet another truth, so they produce a maximum amplitude, go to downwards. Okay, just now it's go upwards, now it's go downwards. But both also is a constructive. Okay, now we go to third part. This one is a superposition of the crest and also the truth. So this one we call it as a destructive interference. Means they want to destroy each other. Okay, now P and Q also move in opposite direction, but the amplitude is one is positive, another one is a negative. So one is a positive A, another one is a negative A. Okay, during the superposition, then what happened? A will minus another A, so this part they will become 0. Okay, this one becomes 0, so they will become flat. Okay, after superpositions mean the P will continue move to right hand side, Q will continue move to the left hand side. Okay, let's see here. Okay, destructive interference that will occur when a crest and also the truth, they are in position to the produce a 0 combined displacement. So from here they will produce a 0 amplitude. You can see this example. Okay, when the crest and the truth they meet at the middle, you see what happened? Okay, they will become flat. After that, chain opposite again. Then the P will continue go to right, Q will go to left. So P move to right, okay, at the middle, become flat. Okay, P will continue go, Q also continue to move. So this one situation we call it as a destructive interference. Okay, now we need to analyzing the interference of the water wave. Okay, if using the water wave means experiment must be related with the river tank. So this one is an example interference. Okay, after you show by the river tank, this one is the result. Okay, they're using two dippers. After that, they will cross to each other. Then we find it. They will bright and dark continuous. Okay, another example. Okay, this one is also same. There's a water interference. Two of the dippers, when they just circle and circle overlap to each other, then you will find the line. Okay, so this one they will demo in the pool. Okay, also can see the same pattern. Okay, so to produce the interference of the pattern of the water wave in the river tank, we can use it. First one, we can using two dippers operate from the same motor. Okay, let's see example. Okay, two dippers. After that, they will produce a circle and circle, is it circular. When they draw the circular, you find it they will overlap to each other. So normally when we start to draw, the first one sure is a constructive. So we draw there's a full line. Okay, the dotted line should be the destructive. They will continuous. Okay, we start constructive, then destructive, then constructive. Then you need to draw one by one. After that, we're going to see which one should be the overlap. Okay, if we're using the plain water wave passing through the two slit also can. Okay, this one is a two slit. When it just pass through, they also produce the same result. Also starting with the crest. Then after that is a trough. Then continue is a crest. Okay, so from here later we find it which part should be the constructive, which part should be the destructive. Okay, so this one we call it is a crest, this one is a trough. So this one also is a crest, this one is a trough. When it just overlap, then we produce constructive and destructive. Okay, now we're going to see the analyzing interference of the water wave. Okay, this one is a double slit. Okay, plain wave. After go through two slits, they will produce interference. Okay, let's see the first one example. Let the motor to vibrate the bar. Okay, you find it, they vibrate the bar. Okay, so that means the wave will pass through the double slit. Okay, let's see the result. Okay, you can see there's a bright and also dark. Bright and also dark. Okay, so this one is a result for the interference. So from here, we need to compare about the interference. The first one is a lambda 1 is smaller than lambda 2. So that means this one lambda should be bigger. Okay, can you see the dark color? The fringes become wider a little bit. This one become narrow. So we see the first one. Okay, two sources. The two sources distance is the same. Just we compare the lambda. Okay, this one's a lambda 1. Okay, can you see the line? There's a one straight line, another straight line. So this one we call it as a distance between the constructive line. Okay, black color is a destructive. No, you can say about there's a truth. Bright color, there's a crest. Okay, when you draw the whole line, we call it there's a constructive interference. Okay, this whole line is a constructive. This one also is a constructive. So that means the line at the middle, the one we call it, we cannot see that one. There's another one that's a destructive. So from here we find it the constructive, go another constructive. This one distant. Okay, we call it label. There's a X. Okay, so now we see the another one. Okay, also the same thing, but you find it the X. This one is a XZ. The X is become smaller. Okay, the distance from the constructive line to another constructive line, they become smaller. This one constructive line to another constructive line, this one become wider. Okay, now we compare another one. Number 3. Number 3 about the A A means the distance between the two sources. This one, two sources become further. This one, two sources become closer. Okay, now we're going to see the X. This one is an X. Distance between two constructive lines. So this one, X is smaller. This one, X is wider. Okay, now I repeat again for the number 3. Okay, the pattern should be the same. Just we need to find out the X only. Okay, now the last one. Okay, this one, X should be bigger. Okay, when I adjust, the two sources become closer. Okay, so this one should be further. Okay, this one is a A2. This one is a A1. This one should be the lambda 1. This one is a lambda 2. Okay, so from here the pattern almost the same. Okay, what will affect the distance between two constructive lines? That's a lambda of the water, that means the wavelength of the water, and also the distance between the source. They will control, they will affect the distance between the constructive line. There's a X. Okay, so from here, interference of the water wave, we need to introduce. This one, S1 and S2 is a source. Okay, just now I show you the source. This one is a, the distance between the source. Okay, bright. Bright area actually what's the meaning? Bright area means the crest, they meet another crest. So they produce the maximum amplitude. So we call it as a constructive interference. If there's a dark area means there is a destructive. Okay, they meet another destructive. So they produce, there is a maximum truth. We also call it constructive interference. Okay, now we're going to see the gray area. Okay, the gray area when I draw. Okay, this one gray area, there's a crest that meet another truth. So from here you find it, there's a destructive interference. So we go through another one. Okay, this one is a pattern of the interference of the light wave. Okay, this one is a experiment. They want to create the interference by using the laser pen. Okay, pass through the double slit, then the screen is here. So the double slit, that means there's a related with the distance between two sources. So from here, double slit with the different distance of the separation, they also will produce a different result. Okay, let's see the first one. Smaller distance of the separation of the slit. Okay, when the slit becomes smaller, you find it bright and dark fringes. There's a bigger size. You can find it at bigger size. If I'm using the larger distance for the separation of the slit, so you find it, the fringes become thinner. Okay, the fringes become smaller. So this one fringes from the another fringes. This one is represented by the X. So just now I showed you the X is it. Constructive to constructive is it. So this one also same. The bright fringes to another bright fringes. This one is an X. When I'm using larger distance of the slit. So example, if the A I make it become bigger, you get this result. If I make the A become smaller, you get the result like this. Okay, the fringe become wider. So constructive interference, they produce a bright fringes. Okay, if there's a destructive, that means they produce is a dark fringes. Okay, now from here is a one of the changing distance of the between the slit. Okay, can you see the slit? When I make it become wider, okay, you find it, the fringes become thinner. So from here, this one is an example using 0.25, 0.5, 0.75, and 1. They calculate by millimeter. This one is a slit. Okay, after that, the laser will pass through the slit. Okay, if I change the color, okay, if I change the color, you also can see what's the difference. Okay, different color also will related with the fringes size. Okay, now I make sure the A constant. That means the distance between two slit constant. I change the color. So the color, how we go to measure? We follow the rainbow color. When the wavelength become bigger, you find it the distance between the constructive means the x also become bigger. So example, red color is a starting. So red color, you find it the fringes must be bigger size. Okay, so this one last one. If I using the orange is a middle, second one. So the orange compared to the red color must be wider. Now we go to last one. Rainbow color, the last one should be the violet. Is it? Violet is a purple color. Okay, you see the purple color. Okay, this one is the smallest one. So from here, conclusion is, if the red color, there's a wavelength longest. Wavelength longest means the interference, the result fringes must be bigger. Lambda bigger, x also bigger. X means the distance between the fringes. Okay, then we go to third one. There's the interference of the sound wave. Okay, let's see the interference of the sound wave using the audio signal generator, then speaker 1 and speaker 2. Okay, this one we put the CRO screen, we go to detect the sound. Okay, from here we get it is a dot and X. Dot means louder sound. Can you see the amplitude become higher? The X one stand for very soft. The sound becomes soft. So that means when you just walk along this distance, you find it you can listen louder and soft, louder and soft. So loud sound is a constructive. Then the soft one is stand for destructive interference region. Okay, let me listen some example. Okay, this one first part, we go to listen. So can you listen? They got a little bit louder. After that, soft a little bit, then go back to the louder. So we repeat again. Okay, this one also same. When they just near to the another speaker, when they just come back, you find it the sound is a little bit lower. Then go back to the louder. Then we go to number 3. Number 3, you can see the meter here. This one is a detector to detect the amplitude. Okay, can you find it? They keep increasing. So from the speaker, they move until the center. Center, they put this one is a constructive line. You find it, the meter show the amplitude keep increasing until maximum. So maximum is 57. So now if I reverse back, you see what happened? So they start from 51. Then they go to the constructive. So this part should be the maximum. Okay, middle maximum, then continuous become lower, then after that go lowest. Okay, so we repeat again the last part. So this one is a interference of the sound. They got lower. We can say about the soft. After that, continuous with the louder. Then soft and louder. Okay, now we need to see about the drawing pattern of the wave interference. Okay, just now I show you. This one is a source S1 and also S2. Okay, this one distance we label as A. Okay, distance between two sources. Okay, the first one, when you draw the half circle, okay, this one is represented by the crest. Okay, then the second one, when you draw that one dotted line, we're using dotted line to draw that one, sure is a truth. Okay, full line we draw by crest, dotted line, there's a truth. Okay, then we continuous to draw. After we draw finish, I want you to do the center one. You can see the center one. Okay, you see this part, this one is a dotted line, join dotted line. Okay, dotted line, the over dotted line means truth meet another truth. Is it constructive? So this one is a constructive. This one also constructive because crest meet the crest. Continue, you draw the dotted until end. So the center straight line sure is a constructive line. Okay, so this whole thing is a constructive point. When we join the line, we never call it as a constructive, we call it as a anti-nodal line. Okay, so beside that, when you see the beside one, dotted line join full line, dotted line join another full line, so we cross. After cross all the line here, then we draw one dotted line. So this one we call it as a nodal line. Okay, that's a nodal line. So that means anti-nodal line is a all constructive point. Nodal line, that's a all destructive point. So they will continuous. Okay, anti-nodal, anti and nodal. So they will continue to draw it. So from here, how to find the x? The x is from the antinode to another antinode. So we call it as x. Or you can say from the nodal to another nodal. That one we call x. Okay, let's see here explanation. Point P is a crest meet another crest. So this one is a maximum. Okay, they become maximum already. So this one is a constructive. Q is a truth meet another truth. Also is a constructive. Point R is a destructive because there's a crest meet the truth. So they become flat. Okay, so dot means the antinode. X means node. Okay, when I draw the line, we call it anti-nodal line. Then the X one is called nodal line. Okay, now we see the relationship between the variable of the interference. Just now I mentioned so many variables already. We got A and X, is it? Now we see what's the relationship. Okay, this one we call A. Okay, this one we call X. X means from the nodal to another nodal. Okay, D. What means of the D? D means the distance from the source until the distance you want to measure the X. So we call it as a D. Okay, now we go and intro some more. Okay, can you see the dotted line? This one is a truth. This one is another truth. So this one we call it as a lambda. This one is a wavelength. Okay, from here, there are four variables, namely lambda, A, X, and D, which are related in the interference of the pattern wave. Okay, let's see the meanings. A, distance between two coherent sources. Okay, lambda means wavelength. Okay, X mean here, distance between the two consecutive nodes, or you say antinode. D is a distance from the two sources to the point of measurement of the X. So normally from here, A until D, the longest one sure is a D, because the distance from the source to the screen must be further. Okay, so I introduced four of the variables. Later we got create the formula to do the relationship. Okay, let's see how to create the relationship for the lambda, A, and X. Okay, first pattern. Okay, A is bigger, wider. A wider, the X will become smaller. So from here, this one is a relationship between the A and also X. Okay, if I make the distance become closer, the X will become further. So there's an inversely proportional. Okay, A increase, X decreases. Okay, this one is an antinode. This one also antinode. So this one we call X. Okay, the second pattern, D constant. Okay, now the A and also the X also. Can you see this one A becomes smaller? This one A is further. This one closer. When the A become closer, can you compare the two diagrams? Pattern 1 and pattern 2, the X. This one X is wider. So from here, I can say when the A decreases, the X increase. Okay, so these two just compare about the A and also the X. Okay, number 3, the pattern 3 is A constant. Can you compare the lambda blue color full line to blue color full line we call lambda. This one also same. This one lambda become bigger already. The wavelength bigger. Okay, wavelength bigger, how about the x? X will increases also. Means the lambda and x will directly proportional. Lambda increase, x also increase. To create the formula, there's a Young's formula. There's a lambda equal ax over d. Okay, a and x inversely proportional. Lambda and x is a directly proportional. So from here, we're going to see example question. Okay, now the light source, they pass through double slit. After that, they produce interference, bright and dark fringes. Okay, first one, the info, they told you the A is a 0.4 mm. Okay, make sure the unit, you need to convert. Okay, if all millimeter is okay, but you see the D is a meter. So you need to convert, become the meter. Okay, X, you also need to convert, become the meter. So the question they give you 3 in 4. Okay, the info is a D equal 3. Then the X I convert to meter, they become 10 power of negative 3. Then this one A also power negative 3. So now the question they ask about wavelength. Okay, what is the wavelength of the light to use? So now we need to apply Young formula. Okay, lambda equal ax over d. You apply all the things, then you find your answer lambda in meter. So this one is a calculation. Say divide by 3. So this one is the answer. Okay, so this one is an example question for we apply the Young formula. Okay, now we're going to see some application. Okay, the application from here, you're going to see the first one. Okay, they show about the bulbous ball bottom of the shapes. Okay, you see first step. Okay, the diagram here. First one, they show the bulbous bowl. Okay, number 2, the wave pattern is up. There's a crest. Okay, then until number 3, they will go, if we hit to the bulbous ball, they become crest also. Now I want you to compare is 3 and also 4. 3 is up. Okay, 4 is a truth. That means if you got bulbous ball, they will meet 3 and also 4 together. Okay, this one is a shape, head of the shape. This one is bulbous ball in front of the shapes. So 3 and 4, when they meet together, they become destructive. When they become destructive means they will reduce the pressure of the wave hit to the shapes. So from here, if 5 is up, that means when they hit the bulbous ball, they should be go down. That's a truth. So when crest meet the truth, they become destructive. Okay, so this one is an example that show when the wave hit the shapes. This one is when the wave hit to the bulbous ball. So after when they mix together, so you see the result become like this. Okay, they will reduce the wave hit to the shapes. Okay, let's see the explanation. Bulbous balls, they generate the water wave, which are interfere destructively with the water wave around the hull. So this causes the water around the ships to be calmer and also reduce the water drag. Okay, this one is an example why they want to put the bulbous balls. They want to reduce the wave. Okay, another one is a coating on the surface of the anti-refraction lenses that caused by the refracted line to interfere destructively. Also same, to interfere destructively. So this one can increase, okay, your vision. So see the diagram here. This one is a lens. This one is an anti-refractions. Means they will refract one time, then will refract the second time. When they refract first time, the wave pattern become like this. When they refract another time, the pattern is another shape. So you can find it. Truth meet the crest. Crest meet the truth. Finally, they will become flat. So that means they don't have any reflections. We can say there's a zero amplitude. So this one, they can make it better for your visions. Okay, the third one also same. Inside the noise cancelling for the headphones. Okay, this one is a speaker produce the sound, This one is a noise create the external sound. When they mix together, you find it, they will destructive, they become silent. So from here, example, they got microphone and also transmitter system in the headphone. They use an aeroplanes produce the sound wave which interdestructive line. So always is an interdestructive line with the surrounding noise. Finally, you find it, the noise, they will cancel each other. They become silent. Okay, that means that finally we cannot listen any noise lah. So this one is a what called it noise cancelling headphone. Okay, so this all is three is a interference application. So important, they want to reduce, okay, make the sound or make the light become destructively. Okay, so we just until here. The next lesson I will explain about the experiment for the sound, light, and also the water interference. So thanks for your watching. Bye.